So I've stopped, and here you go. Now, if I was going to use this for an absolute finished product, I probably would clean this area just a little bit more for the edge, just to make sure that it's a very, very straight edge. But as you can see, it's pretty decent for stainless steel. Now, on video 1, I talked about when you make a mark, you always cut either to the inside or outside or wherever you want to be so that you can clean into that area. Because with a flat wheel on a grinder, something like this with coarse sandpaper now, I'll show you this afterwards, but you can run down this edge and clean that perfectly. But you can see the finished product. And as I indicated, stainless is a little bit tougher to cut than some of the other materials. But I'm pretty pleased with that cut. So I'm going to do a second cut just so that everybody can see it again. I know that, this is all about the cutting, and a lot of times we don't get enough time to view the actual cutting. So I'm going to put my safety glasses back on. Make sure that I'm clamped to the table well. Okay. I've got my ground on the workpiece. I've got my torch. My standoff guide is in place. It's a nice clean run. Ready? Just short of the end on that one. Grab a pair of pliers. Now the reason I made this second cut is already you can identify that the torch tip is dirty. We talked about that. And because of the hardness of the stainless steel, that torch and the tip need to be changed or cleaned to get a perfect fine cut. But still, it's a fairly accurate cut. It will work. That absolutely will grind in, no problem. You'll be deburring it, and then you can sand it right in. Okay, now I'm going to show you a different alloy. We're going to go to the aluminum and actually make a cut. Just so that you can see that using this diverse tool, you're able to cut different materials with it. We'll take this old piece of aluminum diamond plate. We're going to clamp it in place. We're going to put our ground right on the workpiece. We will make a couple of index marks. We'll step in, same thing, we'll step in approximately a ½ inch. Ooh, there's an area here that's already been cut out, so we'll stop right in this area for this first one. That way it'll leave me a little bit of area for demonstration. Again, like I said, then you may find whatever it is that you're going to use for clamping device. Get it close enough that you can clamp it down. Check the alignment. Fairly accurate for what we're doing. Okay. Got our protective eyewear. Our standoff guide. I always run down once to make sure before I start. It's a little rough because the material is old. Okay, ready? Okay, nice cut, nice and clean. So even though the tip needs, or the consumable needs replacing from the stainless steel already, because I've done a lot of cutting with it over the last couple of days, it is still accurate enough to cut the aluminum with no problem. So I'm going to show you a couple other things too that it will do. So plasma cutters can actually gouge, they can trim, cut, it can be used for bolt removal sometimes, or stud removal. So we're still clamped there. Let's come out here. Alright, just positioning clamps in a different spot. Now, you may or may not be able to hear that. You need that air to flow through the torch to cool things down. Okay? Air is used for a couple different purposes within the plasma cutter. It's used as a type of an inert gas, and it's also used for the cooling properties of the equipment. So you want to make sure that that has plenty of airflow. Again, make sure that you read the operator's instructions to make sure that you're meeting the minimum air requirement. Mine happens to be around 70 to 75 psi while it's under operation. So you want to make sure that you adjust the primary regulator so that the second stage has an output of approximately 70 psi under load. So you need to, when you get yours, you need to adjust it, make sure that it's working properly for you, for what you're doing. All right, so now I'm going to do a little freehand. I'm just going to play around with it for a minute so that you can see that. I want to, here, we'll write PSHS. How about that? Let's do that. So I've got my ground on the workpiece. Okay. All right, are we ready? Okay, and that was some freehand. Okay, and that's the back side. You can see it doesn't need a lot of deburring. It's pretty decent, pretty straight cut. Let's do something else. Okay, let's try a little something else. You might like this. Okay, the ground is on my workpiece. I'm going to actually take the standoff guide off. Possibly. It's hot right now, and sometimes they're hard to remove because the end of it has become heated. Make it a little stubborn until it cools off from expansion. Okay, you need to put that in a location that it can cool down safely. Probably just heard the air compressor kick in. You need that. You need that air pressure built up. I'm using an 80-gallon tank with about I don't know if that's about a 2-horse, 3-horse electric motor on it. That's quite substantial for air. You don't need quite that much, but you do need something probably around the 40-gallon range, and something that will maintain, you know, 75 psi for the amount of the duty cycle that you use in the equipment. So you want to make sure that that can sustain that. That's very important. Okay, I believe that I have enough air still in there, knowing my compressor, so I'm going to go ahead and continue on. So I cut you out some quick flames, just freehand real quick to show you that you can be creative with this type of tool. You can do a lot of different things with it. It's a lot of fun. Okay, so all right, we're going to wrap that up for this evening. Thanks very much for joining me, and have a great night.